Hello everyone, my name is Sonia Bujok and I am polymer chemist working in a cultural heritage research group at the Polish Academy of Sciences. And this video is a theoretical introduction to the chemical degradation module of the HERIe platform. So first of all, the chemical degradation of heritage objects refers to degradation of materials which are chemically unstable and are often composed of natural or synthetic polymers. And in general, chemical degradation is manifested by discoloration and loss of mechanical stability, which leads to higher brittleness of the material and its cracking. So here you can see an example of a sculpture with two cones made of cellulose acetate, which first deformed and then cracked and darkened with time. And a very similar manifestation of degradation is observed in Alina Szapoczniko's polyester sculptures, which are stored at the National Museum in Krakow. So in HERIe tool, chemical processes leading to unacceptable changes in the objects are considered in terms of expected object lifetime, which is a quantitative measure of degradation risk. And you can access the chemical degradation module by choosing incorrect relative humidity or incorrect temperature as the deterioration agent. So from the chemical point of view, degradation is a reaction which can be described with Arrhenius equation. And in the classical form of this equation, kinetic rate constant K is a function of temperature, but in the case of many polymers which can undergo hydrolytic degradation, for example, cellulose-based materials, relative humidity is added as the second variable. And in this formula, A and R are constants, and the last parameter in this equation is activation energy E, which value is characteristic for each material, and it provides information on the minimum energy which is necessary to initiate a degradation reaction. So one of the equations relating the degradation rate to relative humidity and temperature, which is used in the HERIe tool, is the so-called preservation index proposed by the IPI for cellulose acetate objects. In this case, proposed activation energy is around 95 kilojoules per mole. And IPI proposed also a time-weighted preservation index, which considers variations of temperature and relative humidity during time intervals. So here we can see how both indexes vary with temperature, which is plotted in red. Both of them increase with decreasing temperature, which means that lowering temperature slows down the degradation and prolongs the lifetime of cellulose acetate objects. This plot also shows the difference between indexes. So values of the PI are only temporary ones, calculated at the exact time, whereas TWPI values correspond to time periods. So another equation used in the HERIe proposed by Sterlitz describes the degradation of paper as an example of cellulose-based material. And in this particular case, it is necessary to take into account another deteriorating factor, which is the acidity of paper, represented by the pH value, or in other words, concentration of hydrogen ions. In this equation, the relative humidity factor is represented by the moisture content in the paper. So here I would like to present how relative humidity and temperature affect the expected lifetime of the fabric. So for this plot, isoperm method proposed by Sebera was used, with the activation energy determined for silk by Luxford. So starting from the reference lifetime at 20 degrees Celsius and 50% of relative humidity, we can extend the lifetime of silk 3 times by lowering the temperature to 14 degrees Celsius, or 10 times by lowering the temperature to 8 degrees Celsius. On the other hand, lowering relative humidity even by 30% will not significantly extend silk's lifetime, and more importantly, further decrease of relative humidity will result in high brittleness of silk. So as you can see, in this case, lowering temperature contributes much more to the extension of the expected lifetime, and such analysis can help to make a decision on the storage conditions. Thank you for watching this introduction, and see you in the next video about the chemical degradation module from the perspective of users.